So what I've done, I've put all the questions that I found from each exam paper and compiled them topic related. So this paper is for Foundation 6.1, so the distance time graph stuff. So I've got my formula sheet there, which is the foundation one, and then we'll go straight to the first question. Now the first thing you notice is there is a lot of information here, and I would always recommend looking at the question before you start looking for the information. Otherwise, you could just scan through it, but I'm going to go straight for the question and then probably need to use this sheet for some information. So the first question says, read the following statements and tick the boxes that are correct. So, the speed limit of 30 miles per hour indicates that it's always safe to travel at 30 miles per hour in that area. Well, that's false, because there's many things come into account there. So you could have poor weather conditions, you could be tired. There's many things that affect stopping distance. So that's just false there. It's not always going to be safe to travel at 30 miles per hour. Cars always have a braking distance of 24 meters at 40 miles per hour. Well, again, I've underlined always there because it's not going to, but if we just check it. So 24 meters, 40 miles per hour. So, yeah, it seems correct, doesn't it? But the fact that it's going to be false because things change. It could be an incline, it could be, there's many things that can come into account. So that is just false. And then it's worth 2 marks. So because those two are false, you could take a pretty good guess that there's going to be 2 ticks by here. Traveling twice as fast always doubles the thinking distance. Now this is different because what it's saying is, even though it's always, on this bit by here, because it's on about speed and it's always going to be that's false. But going twice as fast, because it's not given a value, I think this is going to be true, and we can check this with the diagram. So it says always doubles the thinking distance, so traveling twice as fast. And I've done a couple of calculations there. So thinking distance, when it doubles, from 20 miles per hour to 40 miles per hour, goes from 6 to 12. That's a double. And then I've also taken 30 to 69 to 18. And I've got this information from this diagram here. So my thinking distance is the dark, the first ones. And then my braking distance is the light grey. So that is true. I've ticked that as true. And then the typical minimum overall stopping distance for 50 miles per hour is 53. And it says the typical minimum, okay? So it's not always, so 50 miles per hour is 53 meters. Let's have a look. So it's going to be 15 plus 38. And I think that gives us 53, which is true. So that's the stopping distance. Remember, the stopping distance is braking distance plus your thinking distance. Explain in practice why actual stopping distances may differ from minimum distance shown in the diagram. So this really applies to these two statements that I've clicked incorrect. Because I've said thinking distance may be increased by tiredness, there's alcohol consumption, drugs, distractions like mobile phones or having people in the car. And then your braking distance, which is the time it takes, as soon as your foot hits that brake, then your thinking distance no longer comes into account. Then it's just braking all the way. And these are increased by things like warm brake pads, weather conditions, if it's icy or if it's wet. Even your mass or your load of your car, if you've got a heavy load, then you've got more momentum if you're going at a particular speed. So for 3 marks there, any of those really. Describe the relationship between speed and braking distance shown in the diagram. So we were already told the relationship between speed and thinking distance, that it doubled, and I was able to show that here. But now it wants the relationship between braking distance and speed. So I've done exactly the same. So 20 miles per hour and 40 miles per hour. It goes from 6 to 24. And 6 goes into 24 4 times. So I just checked that I was right then, from 30 to 60. That's all I'm doing. I'm just doubling 30 to 60 to see what my relationship would be. Is it still going to be quadruple? Well, yes, it is, because 13.5 goes into 54 4 times. And I've just got this information from the light grey there. So it increases by a factor of 4. And I've said there, speed doubles, the braking distance increases by a factor of 4. And then using the patterns shown in the data, calculate the overall stopping distance at 80 miles per hour. Well, if I know that thinking distance doubles and braking distance quadruples, then I'm able to take that with me then into this calculation. So at 40, which is half of 80, because it's not given an 80 on this sheet, I've said the thinking distance is 12 and the braking distance is 24. So realistically now, I'm just going to take my thinking distance and double it to 24. I'm going to take my braking distance, I'm going to times it by 4, factor of 4, it's going to give me 96. And then I need to add these two together. And when I add them two together, it's going to give me 120 meters. And that's that question done there. Let's get all these neat and tidy. And then the text suggests that airbags reduce the harm to passengers in the event of accident. Explain how they do this. Well, airbags, they increase the time or the distance, the same thing really, because speed equals distance over time, travelled by the passenger while stopping. It reduces that force acting on the passenger. There's a way you can show that in a calculation, but we're not going to go there for 2 marks. But if you take an example, force equals ma, if you increase the one side, the other side will decrease. So you are actually shortening the time and the distance. Therefore, you're decreasing the force that's acting on the passenger. Name another safety feature. Crumple zones, seat belts, side impact bars. There's 3. It's only worth 1 mark, so any one of those. The text states that it has been estimated that for every 1 mile per hour reduction in mean speed, crash rates fall by an average 5%. Look what they're doing. It looks like a numeracy question. Suggests measures that are taken to encourage people to drive more slowly. Okay, so I was underlining that, thinking, oh, this is going to be something to do with numbers, but then you just put speed cameras, speed bumps, speed limits, public awareness campaigns are all measures that are taken to encourage people to drive more slowly. So they do try and trick you. And it turns out, to answer those questions, I didn't really need much of what was being said in this text here. So I know I've spent like nearly 8 minutes on one question, but it's an important question because a lot of marks was lost on this question. Anyway, put that there.